answer key from last time. A little bit more with like the writing and the laws here. We're doing kind of two sections together. They go pretty closely together. I think they'll work okay together. All right, so take a minute to look at the warm-up questions. There's two there asking you to decide if it's true or false, and then if it's false, you're going to write a counter example. So draw a picture, write an example of something that would be a counter example if it's false. So, what do you guys think about these statements? So, first one, true or false? True or false for that first one? False. So, if you live in Random Lake, then you go to Random Lake High School. All right, so you guys are saying false. So, if it's false, then we have to give a counter example. So, someone give me a counter example. There's probably lots of them. Peyton? So you could maybe not be a high schooler, you could be a middle schooler or elementary, so, okay, what else? There's other counter examples out there. What else do you guys think? Yeah. You could go to a different school. Yeah, so like you could go to, I mean, you can open enroll and go to a different school. You might have friends that live in your neighborhood that don't go to Random Lake, so you could open enroll, so go to, I don't know where people open enroll to here, but another choice, you can choose a different one. How about your parents? Do your parents go to school? No, so there's people that live in Random Lake that aren't school age, so they could be older or younger or babies. So yeah, there's lots of different counter examples to that statement. So just living in Random Lake doesn't automatically mean that everyone needs to go to high school. So, next next one, so getting into the geometry piece of this. If two angles are congruent, then they are vertical angles. Now, if I have vertical angles, they are congruent. So if I flip that statement, if I do the converse of that statement, it's true. So if they're vertical angles, then they're congruent. However, can you think of congruent angles that are not vertical? What do you guys think? Someone come up and draw some? Anyone want to draw me? Does someone want to explain what they have? What's an example? Unless you think it's true. What do you guys think? Anyone have one drawn? Anyone draw an example? So I see some truths. False, is that actually drawing? Oh, I see. So Kansas has a drawing, and I'm going to draw hers. Actually, it happens to be, it's like she copied out my notes. Is that exact drawing. So she drew a straight line with two 90-degree angles. Those are not vertical angles, but they are congruent. So this is false because of that one counterexample. Now, that's not the only counterexample. I could find different angles that are congruent that don't even touch each other. So, just in a drawing, like I could have, and my drawing might be really bad. But like this could be, where should we go? Like this could be 120, and this is 120. Those aren't vertical angles, but they're congruent. So understanding that there are other examples of congruent angles that aren't necessarily vertical. Again, if you flip this statement, if you do that converse of it, it is true. All vertical angles are congruent. So there's like our words are important. In my other class, somebody said, is this English class? And kind of with geometry, a little bit of it seems like it is. So word choice is super important. And so when I ask you to explain something, and you're like, well, you know what I meant, I need you to be a little bit more thorough than maybe you want to be. So we're going to talk about inductive versus deductive reasoning. We've already talked about inductive reasoning, so we'll review that, and then I'll teach you guys deductive reasoning today. Inductive versus deductive reasoning. And I will try to get us outside today because I didn't yesterday. It's going to be a lot of notes, like writing notes today, so maybe we'll just take a break outside and not writing and just walk or something, or do something like that. Okay, so inductive reasoning. We did inductive reasoning when we were talking about following like patterns to make a conclusion. So again, it's nice outside, you assume I'm going to take you outside. You're following those examples or patterns to make a conclusion. Like I said, we do this all the time in life. I'll move away. Those guys don't stand in the way. So inductive reasoning uses patterns or examples to make a conclusion. And I don't really need you to know the different names of these types of reasoning. It might show up in your homework, like what's inductive versus deductive reasoning. But on a test, I'm not going to say identify if this is inductive or deductive reasoning. We just have to be able to use both of the ideas. So I don't need you to know the vocab that goes with it. I just have to have you understand that concept. So now deductive reasoning is a little bit more scientific, I guess I would say. Maybe not scientific, or more logical, that you're going to use facts or definitions or laws to make a conclusion. So this is a little more concrete. So you're going to use facts definitions, laws, it should be of logic, sorry. Laws of logic. To make a conclusion. So this would be an example, if the fire alarm went off right now, you know we would go outside, it's the law, like we have to go outside. The law that if the fire alarm goes off, we can't stay in the building. That's a fact that we know. It's not because, hey, every other time the fire alarm has gone off, we've all seemed to have left the building. It's not just like kind of I would say this is more kind of a whim versus the other one's pretty concrete that like, for sure we have to do this because of this reason. So kind of the same thing with the whole mask thing. And as much as we're like, we all maybe don't agree or don't want to wear them, like it's kind of like it's a law or mandate kind of in that category that we just kind of have to follow it, kind of almost not just because we feel like it, but because it's kind of set in stone for us. So deductive reasoning would be something more like if you were a lawyer and you're trying to prove your case. You can't just say, well, you know, this person has committed crimes before, so I think they're going to commit a crime again. You have to find the facts that show they committed those crimes and kind of the clues and the evidence that shows that. So deductive reasoning is a lot more firm, and it's definitely something that it's for sure. Like, I mean, it says we have to do that, we have to do it. Where pattern, it could kind of change depending how it goes. All right. Are you all good, or were you like hitchhiking on the highway?
No, I got picked up.
Okay, good.
She was hitchhiking and she got picked up on the highway.
Yeah, and now she's here.
See the mechanic, but I got my coffee. So I called him, he's like, well, hi again. I'm like, yeah, I'm on 57, my car is like shut off.
Oh my gosh.
Like,
And this was not even your fault.
No!
Yes.
All right.
And like, the computer shut off, so I couldn't even like,
Oh my gosh. We had that happen in our van, and like, yeah, that was like where the car just like stopped, like everything, like it was like it didn't remember how to like be a car. Like so.
well, it said like it looked like it was buffering on my computer.
Oh yeah.
So it was like system shutdown.
Like loading.
Like, ah.
Oh my gosh. Well, I'm glad you're here safely.
At least
Okay.
it didn't blow off.
Yeah, no blow up.
Well, I had one do that.
Okay. So, we're going to talk about two different laws today. So these are math laws, logic laws. Now, again, you don't have to know the name for the test. Like on the test, I will not say, define what the law of detachment is. But there'll be a problem involving the law of detachment, and you'll have to be able to apply it. Now, your homework might specifically name the law and tell you to use it, but again, it's going to kind of, and actually my car has to, or it's a car question. So there you go, Miss Miller. So, so trying to, it's almost like I had like forethought or it was psychic. All right. So when we talk about these little, like, so it's saying if P implies Q. So if P is true, so like P is my thought, my hypothesis, and Q is my conclusion. If P is true, then Q's got to be true. Excuse me. So it says if a car is out of gas, then it won't start. That is a fact. That's this rule I wrote down. Most people who know that something about cars, and I know that there's cars that don't need gas, but we're gonna go with a gas-powered car. So let's not try to find the loophole here. If a car is out of gas, then it won't start. So if Matt's car is out of gas, what's gonna happen? What's our valid conclusion? Matt's car is not going to start, right? That's all the law of detachment is saying. Now, for whatever reason, and I think it's us being creative, and I love that, like, some of you guys are really creative, you have really great ideas, like I said, like, you'll think of the loophole, you'll think of the funny story that, like, could come from this. I don't really want you to be creative here. I want you just to state the facts, you know, kind of like we're watching a movie, like, about a court case, and, you know, the judge says, state the facts and only the facts, you know, he then stops the person. So I don't want you to say Matt's stupid, Matt should have filled up his car, Matt, you know, like, Matt doesn't deserve to have a license. I mean, like, I don't want you to, like, kind of make a conclusion that's not the facts. So we're just stating the facts here, okay? So that's kind of a weird thing to tell you not to be creative, but don't. Like, just only the facts, ma'am. Like, just stick with it. All right. The next one is a little more complicated. So this is detachment. So again, if basically the if is true, then the then is going to be true. This is called the law of syllogism. Again, don't have to know the name of the law. Like, I don't know, I'm not going to ask you that. You have to be able to use it though. So it says if P implies Q, then Q implies R. So this is like a double imply. Then P implies R must be true. So let me see if I can write this out a little bit better. So if P, then Q. I think sometimes having the if and then there is good. So if P, then Q. So, you know, if the car doesn't have gas, Matt's car won't start. Matt's car won't start, therefore Matt's going to be late for work. So if Q, then R. What we can do is we can skip over Q. So Q repeats itself. Like, why do we have to say the fact that Matt's car won't start? If Matt doesn't have gas, Matt's going to be late for work. We can kind of jump over that repetitive piece of this. So we can just then say, if P, then R. So we're going to skip over kind of like saying that extra piece. So if you get a job, then you'll earn money. If you'll earn money, then you buy a car. So again, I don't want you to be creative. I don't want you to say, no, if I earn money, I'd really like to go on vacation. Like, I want you to kind of, these are the facts. We're going to go with the facts. Don't try to be creative. So what we can do is we can eliminate this double, like, comment. We don't have to say this twice. So what we can do is kind of just skip over that piece. Don't black it out so you can't read it. But if you get a job, why do I have to say you'll earn money, and then if you earn money, then you'll buy a car? If you get a job, what will you do? What's the next step? You'll buy a car. So you can skip over the fact that you're earning money, because we kind of say that twice. We can just jump to, if you get a job, then you'll buy a car. Hopefully it doesn't get stuck on Highway 57. So this law of syllogism allows us to skip over kind of the double repetitive parts that aren't really necessary. Let me see if I have maybe another example of this before we move on. Hold up. Okay, good ones here. I have this kind of weird one that is all about like basically gibberish words or like things that don't exist. Something like this. All right. So here's my here. They say if it's a windboard, so I don't know what a windboard is, and you don't need to know what a windboard is either. There's some like goofy little alien guy. Then it's a glute. If it's a Zeppy, then it's a windboard. If it's a glute, then it has 3 F's. So I'm going to show you guys these different rules using these statements. They don't make any sense, but sometimes it's good to kind of take out what you guys really know about and think about just like the if-then pieces of this. It says Morty is a glute. What can we conclude about him? So what's the fact? If I know Morty's a glute, what do I know about Morty?
He said,
He has 3 eyes. So since this is true, Morty's a glute, he has to have 3 eyes. Does that make sense? So which, like, do you guys see that that's one of our 2 laws here? So that's our law, and again, you don't have to know, that's our law of detachment. We're saying the first half is true, then we can conclude that the second half has to be true. All right, so what if I tell you that Ted, I can't come up with better names, I don't know. So Ted is a Zeppy. Ted is a Zeppy. What can you conclude about Ted? Ted is a Zeppy. Maybe I shouldn't have done that one right away, but we'll see. Ted is a Zeppy. What can you conclude about Ted? What do you think? Ted is a Zeppy. What do you think you can conclude about Ted? I think this one's a little bit bigger than. Anyone see it? So he's a Zeppy, and these don't necessarily have to go in order. So here's him. What do you want to say? That he has 3 eyes. You guys think so? Okay, so Zeppy means he's what? A windboard. If he's a windboard, he's automatically a glute. Since he's a glute, he's also going to have 3 eyes. So that's a kind of a bigger law of syllogism that I can kind of take out that extra information. Now I could say Ted is also a windboard, he's also a glute, he also has 3 eyes. I can say all those things, but we can kind of make that jump and go ahead from there. So that's kind of essentially what you're doing with this. So don't let the order bother you. So like understand that the order can kind of be anywhere there. And we'll hopefully we'll make sure that it makes it clear for you guys, like, again, it doesn't have to be that you tell me syllogism or detachment, just that you can understand what's going on in the argument. All right. Let's finish up with this, not this. Let's finish up with this page, and then we'll take an outside break here in a second. There's not a lot to write here. We just kind of have to talk a little bit. So it says we need to know these rules, but we don't have to memorize them word for word, or like the numbers. So like you don't have to be able to rattle off to me later on, well, today we learned about postulate 8 in geometry class, and now I know that no 3 collinear points, so you don't have to be able to like just rattle that off. The facts that are listed here are things we can assume in geometry. So all of these are facts we can assume. So these are the rules that are used in geometry. These are all things that we can know about a geometric shape. So I know that a line contains at least 2 points. So 2 points make a line is kind of what this first 2 rules are telling us. So in short, that's what's going on there. So if I see 2 points, I can put a line through them. If I see a line that means there's 2 points on it. Like, that's just kind of assumed in geometry. If 2 lines intersect, their intersection is exactly 1 point. I can assume that. Like, so these are just things we can know and assume if we see them in a picture or they describe it. The next 2 are basically saying that it takes 3 points to make a plane. So 3 points make a plane. So this next one just basically says that 2 points are on that plane. The line's also in the plane. Seems pretty straightforward. And then the last one is probably the drawing you probably don't want to draw. But it's basically saying that if 2 planes intersect, so this is like the corner of the room, 2 planes intersect to form a line. So this is kind of our question on our last test. You can try and draw it if you want. So we're trying to show 2 planes intersecting to form a line. Mine's not very good, but you get the idea there. All right, questions there at all? So again, these are just facts that we can assume, kind of know that they're a possibility. So we'll come back from break and we'll talk about how we'll kind of see that in a drawing and finish up this last page. Homework's a little bit on the longer side, but I'll give you guys some time for that. And you have normal AR again today. So why don't we do a quick break outside? So if you guys want to head out, you guys can stay on the sidewalk because the grass is probably wet. If you don't care about getting your feet wet, you can go on the grass, that's fine. So if you guys want to, that side of the room want to head out, you guys can go out this way.
Really? Pretty nice yard work she was.
Well, it's supposed to be good in the sense that, you know, people keep secure the.
Gotcha. I can be here at lunch.
Oh, thanks.
I didn't know you back.
No, it's fine. Yeah.
Sorry, because you're in the cafeteria,
Oh,
right?
sorry, we're gonna pause you here.
Oh.
Yeah. We're going outside. See you later.